Hey guys, it's a nudge job. Today, in this video we will learn 3 things. 1. How you can make a touchscreen smart pen and use it in your smartphone as a whiteboard.
So, here it is, I have my mom's phone here. So first I tried out the operation with the earbud, which ensures that there are no scratches in the screen. But let me tell you that only earbud will not work. So I came up with this homemade magical thing which works as smoothly as a $1,000 smart pen. So let's see how to craft it. So, all you need is a packet of chips, I mean a wrapper which has got a silver wrapping within, and here I am using the packet of garam masala, which was already there in my house. Now, keep the earbud on the logo side and wrap it as cleanly as you can and make sure that the silver part is seen properly outside. Apply cello tapes where necessary to keep your pen clean and tight so that the wrapper never comes out. My friends from Terraper school know that I am not good in arts, so this means you can design this pen in a more creative way. Now, I will show this awesome use of this pen.
Open my phone. I will open this app Jamboard. You can download it from Play Store, and I will click on this plus icon. So as you can see, it's creating a new jam. This jam is not your jam which you eat with bread. So I will just do something here. Just draw anything you want and go back there, and you see the board is being saved up here, and all you need to do is to rename it. So I am renaming it as demo class. So done. So this is everything you need to do in phone. So now I will jump into PC. Now up here in the PC I will open Chrome, and the first thing is that use the same email ID which you used in the Jamboard app in your phone. So I use this email ID in the Jamboard app, so I am using this email ID only. So again, make sure that your account is the same which you have used in the Jamboard app in your phone. Sign in with the same account in both places, in your phone and in your PC. So I will open Jamboard here in Google Chrome. So you can see this demo class file which I created in my phone is up here. So now the thing is, and you see my cursor is up here. First I will clear the frame. So now you see my cursor is up here at this point. Just note it, the cursor is here, and meanwhile I will open the same app in my phone. Okay, I'm not doing anything in my PC, I'm doing everything in my phone now. It's just open, this page is just opened in your PC. If I draw in my phone, suppose I draw this. Okay, wait, just let me show you my phone also. So in phone also I have opened the same demo class, as you can see, and if I draw something up here, suppose I write my name, it appears up here. So in this way you can use your phone's touchscreen feature in your PC. So now let's proceed to solve the question. So I have picked a question from our chemistry chapter solutions. Before that, what you need to do is go to this background and check this rules. So it makes your page a ruled icon. and select this marker tool. Now I will import the question up here. So everything else except the writing part I am doing it in PC. The writing part I am doing with the touchscreen pen, which is homemade, which you saw in the previous process. So I will do everything. I will import the questions picture up here and increase its size. So now I will use a laser tool up here to point out which part I am reading. So you can see it works perfectly. So a solution of urea, molar mass is given as 56, boils at 100.18 degrees. So you can see it's given 100.18 degrees C. It's the boiling point of the solution at 1 atmospheric pressure, and the molar elevation and depression constant of water is given 1.86 and 0.512 per molarity, respectively. The above solution will freeze at, and the options are given. So what we are asked in the question, it is asked what is the freezing point of the solution. So first of all, I will write whatever we have. So from here, for the writing part, I am using my phone as I said earlier. So in my phone, I will suppose I want to write in these two lines in my note. So I'm selecting the pen tool up here, marker tool, and I will write first thing up here. So you will see the magic that what we are given, we are provided with the um, boiling point of the solution. We are provided with the boiling point of the solution, so I represent it with TB. I am doing it with a smart pen, which you which you learned how to make it in the previous process. So TB is given as 100.18 degrees C. Okay, so 100.18 degrees C, and so I will write it as in Kelvin form. It is 373.18. So as you can see, my cursor is up here and the writing part is doing it, which means that the user, means with this account I am using in my phone, that is writing up here. So know that the boiling point of the solvent, means boiling point of the pure solvent is what is our solvent up here is water. It's water. What is the boiling point of water? It's 100 degrees C, so we can write it as 373 Kelvin. And similarly, we know what's the freezing point of the water, so I will write it. What's the freezing point of the water? It's 0 degrees C, which can be written as 273 Kelvin. Now uh, all we have to do is to apply the formula of colligative property for both elevation in boiling point and for depression in boiling point. For the elevation, depression and freezing point. So what's the formula for elevation and boiling point? We know the formula up here is delta Tb is equal to Kb, which is the molar elevation constant, into molality, and we know that the formula for depression and freezing point, I am writing this big because this is the highlighted portion. So it is F into molality. So this small m represents molality. This small m represents molality. So what I saw up here is we need to find the freezing point of the solution. We have the freezing point of the pure solvent, and if we get delta TF and we subtract it with the means the in freezing point case, the freezing point decreases for the solution is always less than delta TF, is less than T naught F. So if I get somehow I get this thing and I subtract it with T naught F, I can it will give me the freezing point of the solution. So I saw that I have delta TB, which is the elevation and boiling point. What is the elevation and boiling point up here is, it's very obvious, it's the delta TB is, now delta TB is T naught B, means TB minus T naught B, 373.18 Kelvin minus 373 Kelvin, which is 0.18 Kelvin, 0.18 Kelvin. Okay, so I'm writing this a bit bigger. Now uh, what I will do, I don't have uh, I don't want to calculate this molality thing. So if I divide both of them, this molality term will get cancelled out. If I divide delta TF by delta TB, what I need is delta TF, so I will keep it as numerator. So I'm showing what I did. What I mean to say is delta TF divided by delta TB. So what I will get when, so this and this will get cancelled out. So I'm left with Kf divided by Kb. Okay. So now what I will do, I have delta Tb, I know it's 0.18 Kelvin. Kf it's given 0.186. Kb also given 0.512. I will now get delta Tf. So delta Tf is equal to, what's the value of Kf? Kf is 1.86. Okay, let me write it a bit smaller. Delta Tf is equal to Kf into delta Tb. Delta Tb will come from up here, cross multiplication, and what I'm left in the denominator this side, it's nothing but Kb. Okay, so till now it's very smooth. Now I will get the delta Tf as delta Tf is equal to, Kf is 1.86 into 1.86 into delta Tb 0.18 divided by what is our kb, 0.512 Kelvin. Okay, so till now I hope everyone has got this. So I will use a calculator up here to save time. Go ahead if you want to do it mentally. 0.86 1.86 into 0.18 divided by 0.512. Okay, so I hope the points are visible up here, and here it is a point, point and a point. So let's see what's the answer for this. So I have got the value of delta TF. Delta TF means the depression in freezing point. So I will write it up here. This is equal to 0.65 4 0.654. Okay, and units are necessary, which is Kelvin. Okay, so now I have T naught F, which is the freezing point of water. I will write it as 0 degree C. It is obviously 0 degree C, so I will write it as 273 Kelvin, and I have delta TF, which is 0.654 654. Okay, so if I convert both of them to degree C, since the options are in degree Celsius, so this will become 0 degree C. So this will become 0 degree C, 0 degree C, and as we know that the change in Kelvin scale is equal to change in Celsius scale, so this will remain as point. These points are not visible, so I'm making a good point. 654 degree C. Okay, so now I will subtract both of them. What I will get, TF is equal to minus 0.654 degrees C. So this is the correct option. Thank you. So I hope I was able to make my point